Optics 4, this is my last video about optics, and it's about curvature. In OCR we need to know about curvature. Okay, this is my point source, but this is a wavefront diagram. Now a point source produces circular wavefronts, but as we move away, notice that they get more and more parallel. So wavefronts from a distant object are straight and parallel. We say they have zero curvature or curviness, but we call it curvature. They have zero curvature if they are straight. Now, here are some plane wavefronts going through a lens. Now, I know that they have come from a distant object because they are straight and parallel. Now, what the lens does is it adds curvature to the wavefronts. It makes them curvy. It adds curvature, so they emerge with positive curvature. The lens adds positive curvature to the wavefronts, and a more powerful lens would add more positive curvature. So if the lens was more powerful, then the focal length would be shorter. Okay, if it was less powerful, they wouldn't add as much curvature and the focal length would be bigger. Looking at this diagram, it's very, very common for you to be asked to draw this, by the way. Now, these wavefronts on the left are not from a distant object. I know because they have negative curvature. Yeah, they're still a bit curvy. They have negative curvature. The lens adds positive curvature. It adds the same amount as before, but because the wavefronts have negative to start with, they don't have as much positive this time, and so they will arrive at a point beyond the focal point. The curvature after equals the curvature before, which is negative, plus the curvature added by the lens. An interesting little equation, because the curvature after is 1 over v. The curvature before, which is negative, is 1 over u. Remember that u is negative. Plus 1 over f is the curvature added by the lens. And hopefully you remember that 1 over f is the power of the lens. So the curvature after is the curvature before, which is negative, plus the power of the lens.